Hi students, okay, today we are learning the topic is vector integral theorems. So in this one totally three theorems. The first one is Green's theorem, second one is Stokes theorem, third one is Gauss divergence theorem. Okay, first first theorem Green's theorem we will discussing. First of all see the statement of the Green's theorem and problems on Green's theorem. Okay, see the first statement of Green's theorem. Let R be a closed region in xy plane enclosed by a simple closed curve C, and if M and N are continuously differentiable scalar functions of x and y in capital R, then integration over C of m dx plus n dy is equal to integration over R, that is a double integration, dou n by dou x minus dou m by dou y into dx dy. Okay, that means here R is any region only. This is any region R, and this region is bounded by a closed curve C in the anti-clockwise direction. Okay, so that is and capital M and capital N are two scalar functions and in x and y in R. R means in the xy plane or any region. Okay, now define that function M and N defined in the region R. Then integration of m dx plus n dy, that means which means the line integral, line integration over C. This is a closed curve. So m dx plus n dy is equal to double integration over R, dou n by dou x minus dou m by dou y into dx dy, and the line integral is equal to the double integral. So this is a now verification this Green's theorem. So we will do the problems. Okay, now this is a statement of Green's theorem. Okay, see the first problem. Verify Green's theorem for integration over C 3x minus 8y square into dx plus 4 minus 6xy into dy, where C is the boundary of the region bounded by x is equal to 0, y is equal to 0 and x plus y is equal to 1. So given region R is bounded by the x-axis, y-axis and the line x plus y is equal to 1, and this boundary is the curve C. Okay, now see the verification now. So this is a given integration of the form integration over C. This is the m dx plus n dy. This is the m, this is the n. That is equal to compare with on both sides. Okay, m is equal to 3x minus 8y square and n is equal to 4y minus 6xy. So now finding dou m by dou y and dou n by dou x. So dou m by dou y is equal to, with respect to y partially, that is equal minus 16y. Dou n by dou x is equal to minus 6y. So that is equal, therefore dou n by dou x minus dou m by dou y is equal to minus 6y minus of minus plus 16y, that is equal to 10y. Okay, now so given region R is the region bounded by x is equal 0, y is equal 0, x plus y is equal 1. See the graph. This is a graph of the given region R. Okay, na? That is equal bounded by x is equal 0, y axis, y is equal 0, x axis, and line x plus y is equal 1. This line is intersecting x axis, y axis at a 1 comma 0, b 0 comma 1. So this is the boundary. This is the boundary C and this is the region R. So to finding the double integration by Green's theorem, so in this region now assumption a vertical strip. Vertical strip means which is slide along x axis. X axis means x limit is constants, y limits function of x. So from the graph the limits are, so x limits are x is equal to 0 to 1. So that is equal, x is equal to 0 to x is equal to 1, and y limits, so this is y is equal to 0 to x plus y is equal to 1 kada. So y is equal to 1 minus x. So this is the limits. Okay now. So that is equal to here. So from Green's theorem, so integration over c m dx plus n dy is equal to integration over r dou n by dou x minus dou m by dou y into dx dy. That is equal to, this is a given assumption given. So this is a line integration given, that is equal to integration over r. So already this value is find out, which is equal to value 10y into dx dy. So in the region r, already finding the limits, x limits and y limits, substituting here. So integration x is equal to constant value, so second time integration x is equal to 0 to 1, and y limits, y is equal to 0 to 1 minus x into 10y dy dx. Okay, now first integrating with respect to y. So integration x is equal to 0 to 1, 10 into integration of y, y square by 2, y limit 0 to 1 minus x substituting into dx. So integration x is equal to 0 to 1, 5 into substituting 1 minus x whole square, y is the upper limit 1 minus x. Okay, now integrating with respect to x. So 5 into integration of 1 minus x square, integration 1 minus x whole cube by 3, but x coefficient minus 1 here, so choosing the by minus 1 constant, limits x limit 0 to 1, that is equal to simplification 5 by 3. So this is the value of the given integration. So now this value is correct or not. Now verification means now finding the line integral. So already finding here double integration, so 5 by 3 is correct or not. Now finding the line integration, that is a LHS part over C. Okay na? So that is equal to here. Now verification. So now to evaluate, this is a line integral, that is equal to integration over C f bar dot dr bar, where f bar is equal to 3x minus 8y square I plus 4y minus 6xyj, where dr is equal to I dx plus j dy. So and given C is the boundary of the region bounded by x is equal to 0, y is equal to 0, comma x plus y is equal to 1. Since the curve is bounded by 3 curves, say, so already saying in the graph, see the once again graph. So chudandi, the graph is boundary the C kada, ante x axis, this is the x axis, and this line x plus y is equal to 1, and y axis, and this is the first curve C1, this is second curve C2, this is the third curve C3, and a given C is bounded by 3 lines, and C1 means OA line plus C2 line AB line plus C3 line BO line. So now integration over C is equal to the sum of the line integral over C1 and C2 and C3. Now finding integration over C1 plus C2 plus C3, that is the required line integration of the given curve. Okay na? See that here. Okay, say the C1 curve OA, C2 AB, C3 BO. So integration over C is equal to integration over C1 plus integration over C2 plus integration over C3. Okay na? Finding individual, now adding all, that is the required line integration. So that is equal to here. First along the curve C1 OA, what is the OA line equation? Equation of C1 is equal to x-axis. X-axis means y is equal to 0. The y means y is eliminated. So dy is equal to 0. Now choosing x limits. What is the x limits along C1 curve? 0 to 1. From 0 comma 0 to 1 comma 0 the line. So x limit 0 to 1. Y eliminated here. So therefore integration over C1 is equal to, substituting here y is equal to 0 and dy is equal to 0. So, along C1 3x into, this is a 0 into dx is 0, y is equal to 0, y is equal to dy is 0. That is equal to x limits here, x is equal to 0 to 1, 3x into dx. 3 into integration of x square by 2, x limit 0 to 1, that is equal to 3 by 2. This is the first line integral over C1. Okay, similarly we have to finding along C2 and C3. So that is equal to here, along the curve C2 AB. What is AB line equation? So AB line equation is x plus y is equal to 1. So now substituting y is equal to here and y eliminated, y place low 1 minus x replacing. So dy is equal to here minus dx. Now choosing x limits. X limits means from a to b, a 1 comma 0 to b 0 comma 1. So x limits means 1 to 0. So x limits are 1 to 0. Okay, so next one, integration over C2 is equal to, this is a given, that is equal to x place low, sorry, y place low 1 minus x replacing, dy place low minus dx replacing. That is equal to along C2, integration over C2, 3x into 8 into 1 minus x whole square into dx plus 4 into 1 minus x minus 6x into 1 minus x into minus dx. So now dx is a common, remaining all simplification. So integration x limits 1 to 0. So simplification is totally expand and adding and subtracting. That is equal to, simplification is integration 1 to 0 minus 14x square plus 29x minus 12 into dx. Now integrating with respect to x. So minus 14 into x cube by 3 plus 29 into x square by 2 minus 12x. Limits 1 to 0. Lower limit 0, upper limit 1. That is equal to 14 by 3 minus 29 by 2 plus 12. That is equal to 13 by 6. This is a line integration over C2. So next third line along C3. So along C3 line BO. So what is the line equation of BO? X, y-axis here. Y-axis means x is equal to 0. The dx is equal to also 0 and x is eliminated. Choosing the y limits. Y limits means BO. B is a 0 comma 1 to 0 comma 0. So y limits 1 to 0. So y limits are 1 to 0. Therefore integration over C3, that is equal to here. So x place lo 0 only. Dx place lo 0. So this is the total value 0 first one. Next 4y minus 6 is 0 and 4y dy. So that is integration y is equal to 1 to 0, 4y into dy. So that is equal to 4 into integration of y square by 2. Y limits 1 to 0, that is equal to lower limit 0, upper limit 1, that is minus 2. This is the integration over C3. So now adding all along C1 plus along C2 plus along C3. That is the required line integration over C. That is equal to, from equation 1. So integration over C is equal to first value 3 by 2 plus second value 13 by 6 minus third value 2 minus 2. So adding all, that is 5 by 3. See that already finding in the first value double integration over R is 5 by 3 and this is a line integration over C, that is equal to 5 by 3. So line integration is equal to the double integration. So see that both values are equal. Therefore hence Green's theorem is verified. So this is the problems on Green's theorem verification. Okay. See the next example. So verify Green's theorem for integration over C 3x minus 8y square into dx plus 4y minus 6xy into dy, where C is the boundary of the region bounded by y square is equal to x and x square is equal to y. So this is the previous question is also same, but region is the different. So now verification on different region. Okay, now so previous region is triangle region. So this is the region is bounded by two parabolas. Okay, now see that verification is. So let the given line integration over C is equal to assumption integration over C m dx plus n dy, where m is equal to 3x minus 8y square, n is equal to 4y minus 6xy. So that is equal to here, dou m by dou y is equal to minus 16y, dou n by dou x is equal to minus 6y. That is equal to dou n by dou x minus dou m by dou y is equal to minus 6y plus 10y, 16y is equal to 10y. So let R is the region bounded by two parabolas. Y square is equal to x and x square is equal to y, and both are intersecting at 0, 0 and 1, 1, and both parabolas in the xy plane intersecting 2 points 0, 0, 1, 1. So that is equal to here. See the graph. Question. So x axis, the y axis. This is the first parabola. This is y is equal to x square and x is equal to root y. Both are same. Y is equal to x square. So second curve, this is about y axis. This is x is equal to y square. Okay, na? Both are intersecting at 0, 0 and at 1, 1. So this is a line. Boundary is the line. This is a C and C. And also C is the bounded by, the boundary is bounded by two curves. This is the C1. This is the C2. And along the line is the only bounded by the two curves. That is OA C1 and AO, that is C2. Okay, na? First of all, finding the double integration by using the Green's theorem. Next, verification, finding the line integral. Okay, na? So that is equal to here. So in this region now, assumption any vertical strip or horizontal strip. Okay, na? So now I am choosing here a horizontal strip. Horizontal strip means slide along y axis. The y limits are constants, x limits are functions of y. So that is equal to here. Let horizontal strip in our y limits are constant. Y is equal to start from 0, 0 to 1, 1 and the y limit 0 to 1. And x limits left to right. Left side is the curve is x is equal to y square to x is equal to root y. So this is the limits in the region R. Now finding the integration of given value. That is equal from Green's theorem. The line integration is equal to the double integration over R. So given line integration is, so this is a given line integration is equal to integration over R. So this value is equal to 10y into dx dy. So that is equal to y limits constant, y is equal 0 to 1, integration x limits, x is equal y square to root y, 10 into y dx dy. First with respect to y. So that is equal to here, x limits functions of y. So first integrating with respect to x. Okay, na? Second integration with respect to y, and the y limits constant, there is a second time integration. Okay, first time integration. So here integration y is equal 0 to 1, 10y is the constant, integration of 1 with respect to x. So x. So x limits y square to root y. Root y is the upper limit, y square is the lower limit. Substituting here, integration y is equal 0 to 1, 10y, substituting root y minus y square into dy. So now integrating with respect to y, substituting multiplication is 10 constant, y into root y means y power 5 by y power 3 by 2. y power 3 by 2 integration y power 5 by 2 by 5 by 2 minus y into y square means y cube integration y power 4 by 4. So y limit 0 to 1, upper limit 1, lower limit 0. Substituting here after simplification, this is a 2 by 5 minus 1 by 4. Simplification is 3 by 2. This is the double integration value of by Green's theorem 3 by 2. So this value is correct or not? Now finding the LHS part. LHS part is line integration over C. But we know that from the graph the line C is bounded by the two lines and two curves, OA line and AO line. Okay, now integration over C is equal to integration over C1 plus integration over C2. Okay, now so that is equal to, now verification is so now let the given line integration over C is equal to f bar dot dr bar, and f bar is equal to vector this one and dr bar is equal to this one. Okay, now so since given region is boundary of the region bounded by y square is equal to x and x square is equal to y. Therefore, since the curve is bounded by two curves from the graph already I told, that is C1 and C2 is equal to, C1 is OA curve, C2 is equal to AO curve. See the once again the graph. Okay, now therefore integration over C is equal to integration over C1 plus integration over C2. Now finding both values. Okay, continuation. So along the curve C1 is OA. So what is the OA line equation is first parabola about x-axis here. X-axis means here assumption x is equal to root y. X square is equal to y and y is equal to x square. This is the first curve C1. And y is equal to x square means y is eliminating and y place lo x square replacing and here y ni eliminate chestunnam. Again dy is equal to here 2x dx, and now choosing x limits. X limits means from 0 to a, 0 comma 0 to 1 comma 1. So x limits 0 to 1. So that is x limits 0 to 1. So therefore integration over C1 is equal to here x y place lo x square replacing and dy place lo 2x dx replacing. Okay, na? That is equal to integration over C1 3x into 8 into y square means x square whole square into dx plus 4 into y square minus 6x into x square into dy is equal to 2x dx. Now simplification, dx common. After simplification total 3x plus 8x cube minus 20x power 4 into dx. Now integration with respect to x. X limit 0 to 1. So that is equal to 3 into x square by 2 plus 8 into x power 4 by 4 minus 20 into x power 5 by 5. Substituting limit 0 to 1. That is 3 by 2 plus 2 minus 4. Simplification is minus 1 by 2. This is the first value along C1. Similarly, we have to finding along C2. So what is the C2 line? The C2 line is the parabola about y axis, that is equal to x square is equal to y, sorry, x is equal to y square about y axis here. So C2 line is x is equal to y square and x place lo y replacing and x eliminated and dx is equal to 2y dy. Now choosing y limits. AO line kada, from the point A 1 comma 1 comma 2 1 comma 2 0 O comma that is 0 comma 0, that is y limits are 1 to 0. So y limits are 1 to 0. It is equal to integration over C2 is equal to this one. X place lo y square replacing dx place lo 2y dy. Along C2 that is equal to 3y square minus 8y square into 2y dy plus 4y minus 6y square into y into dy. After simplification is y limits 1 to 0 minus 16y cube plus 4y into dy. Integration with respect to y minus 16 into y power 4 by 4 plus 4 into y square by 2. Limits 1 to 0. Upper limit 0, lower limit 1. That is equal to minus 0 plus 0, that is plus 4 minus 2. That is equal to 2. No? So that is equal, adding both from equation 1 along the integration over c is equal to first value minus 1 by 2 plus second value 2. That is equal to 3 by 2. So 3 by 2 is also same to the double integration, the right side value 3 by 2. This is the left side value 3 by 2. And the both are equal. So that is equal to, hence Green's theorem is verified. Okay, na? This is the verification on Green's theorem. Okay, see the next one. So next example, apply Green's theorem to evaluate integration over c 2xy minus x square into dx plus x plus y square into dy, where c is the boundary of the region bounded by y is equal to x square and x is equal to y square. Okay, na? This is the only Green's theorem applied but not verification. Okay, na? Given line integration is equal to the double integration by Green's theorem, and now finding only double integration, that's all. That is RHS part. That is equal to given integration over c, this is m dx plus n dy. M is equal to here 2xy minus x square, n is equal to x plus y square. So dou m by dou y is equal to 2x, dou n by dou x is equal to 1. Okay, na? So dou n by dou x minus dou m by dou y is equal to 1 minus 2x. So given region is bounded by the two parabolas, y is equal to x square and x is equal to y square. Both are intersecting at 0, 0 and 1, 1. That is equal to same. So in the region or assumption a horizontal strip or vertical strip, we can choose in anyone, either choose vertical strip or horizontal strip. Now choosing the horizontal strip straight along y axis, y limits are constants and x limits are functions of y. So that is equal to here y limits, y is equal to 0 to 1, x limit y square to root y. Okay, na? So that is equal to here, find the integration by Green's theorem. So this is a Green's theorem, line integration is equal to double integration. So this is a given line integration is integration over c 2xy minus x square into dx plus x plus y square into dy is equal to integration over r. So dou n by dou x minus dou m by dou y is equal to value 1 minus 2x into dx dy. That is equal to integration, y limits constants in the second time integration, y is equal to 0 to 1, integration x is equal to y square to root y, 1 minus 2x into dx dy. Now first integrating with respect to x. So integration y is equal to 0 to 1, integration of 1x minus integration of 2x, x square by 2 cancel. So x limits y square to root y into dy. So y limits integration y is equal to 0 to 1, substituting x place to root y, upper limit root y minus y minus of y square plus y power 4 into dy. Now integrating with respect to y power 3 by 2 by 3 by 2 minus y square by 2 minus y cube by 3 plus y power 5 by 5. Substituting the limits 0 to 1, that is 2 by 3 minus 1 by 2 minus 1 by 3 plus 1 by 5. That is equal to simplification 1 by 30. So this is the required value of the given line integral by using Green's theorem. Okay, see the next example. So apply Green's theorem to evaluate integration over c e power minus x into sin y dx plus e power minus x into cos y dy, where c is the rectangle with the vertices. So given vertices 0, 0, 5, 0, 5, 5 by 2, 0, 5 by 2. That is the region is rectangular region bounded by the 4 lines here. Okay, na? So given 4 vertices. So similarly same procedure, only finding the value only. There is not verification. So given line integration which is converted to the double integration. Okay, given form integration of m dx plus n dy. M is equal to a e power minus x into sin y and n is equal to e power minus x into cos y. So dou m by dou y is equal to e power minus x into cos y. Dou n by dou x into minus e power minus x into cos y. Dou n by dou x minus dou n by dou y is equal to minus 2 into e power minus x into cos y. Okay na? Given region is a rectangular region. No? So let R be the region bounded by the C is the rectangle with vertices, and now let a vertical strip in R. Vertical strip or horizontal strip, choose anyone. Because given region is rectangular and x lim is constant, y lim is constant, both are constant. Now choosing anyone. Now integrate with respect x or y. X lim is constant and y lim is constant. See that. So clearly graph. The region R is bounded by the 4 lines OA, AB, BC, CO. So in this one now choosing a vertical strip. So this along x-axis and x limits em hota ikkada 0 to pi. Y limits y is equal to 0 to y is equal to 5 by 2. That is equal to here. X limit 0 to 5, y limits 0 to 5 by 2. So now finding the integration from the Green's theorem. So this is a Green's theorem. Line integration is equal to double integration. So this is a given line integration is equal to integration over R. So this value is minus 2 into e power minus x into cos y into dx dy. Okay, limits are y limits constant, x limits constant. So minus 2 is the common. Y is integration y is equal to 0 to 5 by 2. Integration x is equal to 0 to pi e power minus x into cos y into dx dy. So e power minus x into cos y. X limits constant, so y limits constant. Function we are separating. We can separating functions also. So minus 2 into first function e power minus x integration e minus e power minus x. X limit 0 to 5. So integration of cos y, that is sin y. Y limit 0 to 5 by 2. So that is equal substituting minus 2 into x upper limit 5 minus e power minus 5, lower limit 0 kada. Minus of minus plus e power 0 1. Ikkada into sin 90. Sin 90 is 1 minus sin 0 0. So that is equal to here 2 into e power minus 5 minus 1. This is the required value of the given line integral by using the Green's theorem. Okay. So yeah, thanks for watching this video. For more videos, please do subscribe my channel, like and share it. Thank you.